Thank you for your interest in Bharat AI SOC Student Challenge. This initiative, driven by Arm and Arm Education, aims to support skill development in India by encouraging students to tackle industry relevant problems and devise innovative and impactful solutions. We are proud to partner with Mighty C2S program as well as collaborate closely with IT Delhi, our lead academic institution in this endeavor. I extend my gratitude to Ministry of Electronics and IT as well as IT Delhi for their support in this exciting initiative. Good luck to all the participating teams.
Hello everyone, I am Priyanka, a research scholar at IIT Delhi. I am a program assistant for Bharat AI SOC Student Challenge and I'll be your mentor for problem statement 1. In this presentation, I will walk you through the problem in detail so that you clearly understand the objective and how to approach its solution. Today, voice assistants such as Alexa and Google Assistant are widely used. However, they rely heavily on cloud-based processing. This constant connection to the cloud raises serious concerns related to user privacy, as these systems continuously listen to their surroundings. In addition, they depend on a stable internet connection and often suffer from increased response latency, especially in regions with limited or unreliable connectivity. To address these challenges, the focus of this problem is to develop an offline Hindi voice assistant that processes all data locally. The target platform for this solution is an ARM-based system on chip such as a Raspberry Pi. This kind of offline Hindi voice assistant is especially useful in rural areas with poor internet connectivity, in healthcare environments where privacy is critical, and for elderly users who prefer simple voice based interaction in local languages. Since all processing happens locally, the system is reliable, secure, and accessible. To successfully address this problem, we need to focus on three major aspects. The first one is the solution must be deployed entirely on the embedded device, ensuring fully offline operation. The second aspect is that the system should reliably understand Hindi voice commands. And the third one is that despite the hardware constraints, the solution must deliver low latency responses for a smooth user experience. For this solution to be complete and correct, it is essential that all three aspects are implemented. This slide shows the overall system architecture of the offline Hindi voice assistant. The pipeline begins with a USB microphone which captures the user's spoken Hindi command. The audio is then passed to the automatic speech recognition module, which converts the speech signal into text entirely on the Raspberry Pi. Once the text is generated, it is processed by a Python-based intent recognition module, where the system identifies the user's request and determines the appropriate action. After the intent is resolved, a textual response is generated and sent to the text to speech module, which converts the text back into spoken Hindi. Finally, the response is played through a speaker. Since all these steps are executed locally, the system operates fully offline, ensuring low latency and strong privacy guaranteed. Here we discuss the hardware and software components required to build the offline Hindi voice assistant. On the hardware side, we use any ARM-based device like a Raspberry Pi, which serves as the main processing unit. A USB microphone is used to capture the user's voice input, and a speaker connected through the 3.5 mm audio jack or HDMI is used to deliver the spoken response as the output. On the software side, however, The entire system is implemented in Python. PyAudio is used for real-time audio input and output. For speech recognition, we use an offline ASR engine such as Quirky STT or a fine-tuned Wave2Vec 2.0 model. For speech synthesis, an offline TTS engine like eSpeakNG or Festival is used. Custom Python logic for intent recognition and command execution. And all these components will be run locally on the device, on the ARM-based device, here Raspberry Pi, ensuring offline operation and user privacy. Now we highlight the key performance targets expected from the voice assistant. Number 1 is the system is designed to achieve a response time of under 2 seconds from the time the command is given to when the response is played back. This ensures a smooth and natural user experience. The second one is the assistant should accurately recognize 10 to 15 predefined Hindi voice commands, which allows us to balance recognition accuracy with computational efficiency on embedded hardware. And the last important target is that it should be fully offline. The system must function without any internet connection or without relying on GPUs or cloud resources, making the solution suitable for real-world embedded or edge deployments. Here we outline the key deliverables expected from the project. Firstly, the students are required to submit the complete source code for the offline voice assistant, covering the full pipeline from audio input to spoken output. Along with the code, proper documentation must be provided, explaining the system architecture, the choice of ASR and TTS models, and any fine-tuning or optimization steps performed. A demo video is also required to demonstrate the working system, showing responses to multiple Hindi voice commands. Finally, students must submit a short technical report describing the overall approach, challenges faced in Hindi speech processing, and the achieved performance metrics. Through this project, students will gain hands-on experience in building an embedded offline voice assistant from end to end. They will learn how to integrate speech recognition, intent processing, and text-to-speech into a single working system on resource-constrained hardware. The project also helps in understanding the challenges of regional language processing, particularly Hindi, including accent variations and data limitations. In addition, students will develop practical skills in edge AI and privacy-preserving system design, which are increasingly important in real-world applications. Overall, this project provides strong exposure to embedded AI, speech processing, and real-time system integration. This project demonstrates how powerful privacy-preserving voice assistants for regional languages like Hindi can be built entirely offline on embedded edge devices. For further queries, you can email at the given email address. All the best, guys. May your ideas turn into impactful solutions.